what we are going to be doing is we're going to be working with identity. Now, today is not probably my most favorite day of the chapter, but I have to introduce you to the identities and show you how we can use them to simplify. But once we get to tomorrow, when we verify identities, we'll have a start and a finish, and we'll kind of know when we're done. Today, you might feel like, I'm not really sure where I'm going. I don't want you to feel frustrated. I want you to know that that's kind of a common feeling, but tomorrow it will get better. Okay? But first we need to write down our fundamental identities. So we're going to write down more than 8, but we call these the 8 fundamental identities. There's 8 main ones, and then there's a couple, there's like 3 that are like implied. Okay? So the first set of identities, and these are important, like you'll want to come back to these often, so I don't know how you like to make things stand out in your notes, but these next 2 pages, you need to make them stand out in your notes, okay, like my next 2 pages. Okay, the reciprocal identities. When you see the word reciprocal and we're talking about trig, what do you think of? Okay, like 1 over something. Okay, what did you say? Something was said over here. Okay. Okay. Cosecant, secant, and cotangent. We call those the reciprocal functions because, like Kaya said, they're 1 over sine, 1 over cosine, 1 over tangent. These are our reciprocal identities. If you see 1 over sine theta, you can change it to cosecant theta, or x, or whatever the angle is. If you see 1 over tangent theta, you can change it to cotangent theta. They're the same thing. Okay? Now, these are the 3 main ones, but I'm going to go ahead and write 3 more that I think are just kind of implied, but I want you to have them like officially written down. We're just going to kind of do the reciprocal of these, okay? Sine is the same thing as 1 over cosecant. Cosine is the same as 1 over secant. And tangent is the same as 1 over cotangent. If you know the 3 on the left, then you should know the 3 on the right. Okay? More often, you're probably going to see these on the left, but every once in a while, you might need one of these from the right. And so I just want to make sure that we're all on the same page. Okay? Do you think you can remember these? Do you think that you kind of already knew them without knowing that they were identities? Okay. So an identity is like something that's true. It's something that's a fact, like in math. If you see cosecant, we can change it to 1 over sine, or vice versa. Okay. I need you to remember these. Okay. The next set are called the quotient identities. And I feel like you already know these. Quotient is a fancy word for division. Do we have a trig function or 2 that is the quotient of 2 others? What do you say? Oh, and what is tangent? From the unit circle, we took y over x, right? But the y represented sine and the x represented cosine. So this can be applied to any angle. The tangent of theta equals sine over cosine. I said there were 2. What would the cotangent ratio be? Cosine over sine. Okay? These are very handy. If you see sine over cosine, you can change it to tangent. If you have tangent, you can change it to sine over cosine. Do you feel like you already kind of knew these? from working with the unit circle? Okay, you need to remember these. You need to recognize them. But I feel like you already kind of knew them without knowing that you knew them. Okay. The biggest ones that you're going to have to memorize are what's called the Pythagorean identities. Okay. On our unit circle, we have cosine, sine as our x and y coordinate, right? Well, if we make this a right triangle, we know that our radius is 1, this is x, this is y. If we use the Pythagorean theorem, x squared plus y squared equals 1, we could write sine squared plus cosine squared equals 1. I wrote it as y squared plus x squared equals 1, but it's just a lot easier to recognize as sine squared plus cosine squared. This is a very important identity. Sine squared plus cosine squared equals 1. We're also going to work with this rearranged. Like I could say that sine squared equals 1 minus cosine squared, and you would be able to use that as well, like if you rearranged things. Okay? Now, I'm going to write this over here. Don't write this with me. But let's go ahead and, because there's two more Pythagorean identities, I want you to understand where they come from. If we divide both sides by cosine squared, okay, what did we say sine over cosine was? Tangent, right? So sine squared over cosine squared would be the same thing as tangent squared. Cosine divided by cosine would be 1. And then 1 divided by cosine squared, if 1 over cosine is secant, 1 divided by cosine squared is secant squared. Write that Pythagorean identity down, please. Tangent squared plus 1 equals secant squared. Okay. Then let's take our same original Pythagorean identity, and instead of dividing by cosine squared, let's divide both sides by sine squared. Okay, so now we have sine squared over sine squared plus cosine squared over sine squared equals 1 over sine squared. Okay, there's our third Pythagorean identity. You can either memorize the 3 or memorize the first one and remember how to get the second 2 or the second and third one from there. But these 8 identities that we just wrote down, they need to be memorized in order to be able to do what we're going to do today through Friday. Okay, now I don't expect you to have them memorized today, but I need them to be fairly memorized tomorrow and all the way memorized Wednesday. Okay? That way you can have more success with proving identities to be true. Okay? Now before we get into actually using these to simplify, we do need a little bit of practice factoring. Okay? There are going to be a number of times, not only in this section and the section tomorrow, but even next week, where we're going to have to factor, but using trig expressions. So I just want a little bit of practice before we start using our identities. So go ahead and write this down. Now, is cosine squared x minus sine squared x something that we wrote down? Ours was addition, right? Okay. Now, in a situation where we were simplifying, factoring probably wouldn't be helpful, but I wanted a basic example so you could see the pattern, okay? I don't want you to forget about our difference of squares. Do you remember how a squared minus b squared factors to a minus b times a plus b? Right? Okay, so this is cosine squared x minus sine squared x. Is this a difference of squares? Okay, so we can factor this to cosine to a minus b times a plus b. This is what I'm more concerned about you practicing. Write it down. I'm asking you to factor this trig expression, but it looks like a trinomial, doesn't it? Okay. Now, some of you may feel very uncomfortable that we are factoring with trig functions instead of x's. So if it makes you feel so uncomfortable that you're just not really sure, I would encourage you to just off in your margin, write this as 4t squared plus t minus 3. Does this look something more like what you're used to seeing? Okay, so let's factor this. Okay. Well, we know for sure, well, there's a couple different ways we could get 4t squared, correct? We could do 4t times t, right? And we need to get a negative 3. So we know 1 times 3 is going to work, but one needs to be positive, one needs to be negative. I know the answer. I want you to help me. Where should the 3 go? Where should the 1 go? Here? Okay, which one needs to be positive? So here we have negative 3t, and here we have positive 4t. Does that add up to be the 1t in the middle? Okay, so if this expression factors to this, then 4 tangent squared x plus tangent x minus 3 would factor to 4 tangent x minus 3 times tangent x plus 1. Essentially, I just made the t's tangents, and that's why I use t. Okay, if it's sine, I would use s's and then change all the s's to sine of x. Okay. I would change them to a single letter until you get more comfortable factoring using trig expressions. All right, let's get into some simplifying. Are you ready? Okay, so the first part of your homework is going to be this. But a bulk of your homework is going to be, I give you an expression and I ask you to simplify it. Okay. We just got done talking about factoring, right? This is something that you got to look for. Okay? Do both terms have a sign of x inside? So what we can do, we have something called the GCF, right? Sign of x is in common, so we can factor it out. If we divide it out of the first term, we're left with 1. Minus, if we divide it out of the second term, we're left with cosine squared. Look back to your identities. Go back to that trig identity. Could you rearrange a trig identity with 1 and cosine squared? How could we rearrange it? Could we move this over so that 1 minus cosine squared x equals sine squared x? You see how I did that? I just moved the cosine squared over. So this 1 minus cosine squared x is the same as sine squared x. So what do we have? We have sine cubed. Do I need to talk about this again? Yeah. Okay. So our Pythagorean identity is sine squared plus cosine squared equals 1. Well, if I rearrange, if I take cosine and I subtract it over to the right side, then our identity is 1 minus cosine squared, and we're just left with sine squared here. So since we have 1 minus cosine squared, we can replace it with sine squared. All right, let's try another one. Okay, any ideas?
We could do like a quotient identity.
Okay, so this cotangent right here, we could change to what? Cosine over sine?
Yeah.
Okay. So I'm just going to start making little notes to myself, okay? We use the quotient identity here. Okay. So what we have is sine of x plus cosine squared x over sine of x. Okay, because we multiply. All right. Well, that kind of helped. How can we add two things together where one is a fraction? If I had 3 plus 5/6, well, let's do something better. 7/6. If I had 3 plus 7/6, what would I do to add those together? We would make common denominators, wouldn't we? Okay, can we do that here? We kind of have to, okay? So our common denominator would be sine of x. So I'm going to take this first fraction, and we need a denominator of sine of x. So I'm going to multiply by sine over sine, because we can't change the value. We have to multiply by 1. Okay. So right now we have sine times sine is sine squared plus cosine squared all over sine. I see pages flipping. Something's looking familiar there. Okay. What is sine squared plus cosine squared the same as? It is the same as 1. So we can use the Pythagorean identity to replace sine squared plus cosine squared with 1. One more step. What's 1 over sine x the same as? Let's change it then. Okay, we have a reciprocal identity that tells us that 1 over sine is the same as cosecant. Okay. Yes.
Are we gonna have to like list those out on quizzes or tests, kind of like we did proofs and geometry?
So when we get to tomorrow, I am going to ask you to do this, which is why I'm kind of starting it today. First of all, if you're going back and looking at your notes, I think sometimes it's helpful to see what it was that we were doing. But tomorrow when we get into verifying identities, it is kind of like a proof, and there's a lot of different ways we could go about doing it. So for me or for your peers to follow your work, I'm going to have you tell me what you're doing in each step. That way, if there is a mistake, we can figure out what it was and what you were trying to do. Does that make sense? Okay. We are going to do one more, but what I want you to learn from this right here is that if you have fractions that you're trying to add together, you're going to need common denominators. That's going to be a very big thing. You're going to do it a lot. Okay? Okay, this will be our last example of this kind, and then we're going to do what's called the trig substitution. Okay, so when we have two terms in the denominator, we're kind of stuck because we cannot split a fraction up by its denominator. Okay, now this is a strategy that we're going to talk more about tomorrow, but I know that multiplying by 1 minus sine of x is going to be helpful. Okay, and we can't just multiply the denominator by something. We would have to multiply numerator and denominator by the same thing as to not change the value. But what do we call 1 plus sine of x and 1 minus sine of x? What's the relationship? That's where we're going to get to. Where they're going to create a difference of squares because they are, starts with a C-O-N. There we go. 1 minus sine of x and 1 plus sine of x are conjugates because when you multiply them together, we get a difference of squares. Okay, so we multiplied by the conjugate. Okay, so what's that going to do? Earlier we looked at 1 minus cosine squared, correct? Do you think we could rearrange this the same manner for 1 minus sine squared? If we rearrange this, 1 minus sine squared is the same thing as cosine squared. So what we can do is we can use our Pythagorean identity to write this as cosine squared for our denominator. Well, now we have it to where our numerator has 2 terms and our denominator only has 1. So we are allowed at this point to break up a fraction. We cannot do that if we have 2 terms in the denominator, but if the 2 terms are in the numerator, that's fine. Okay. So now, what's 1 over cosine squared the same as? Well, what's 1 over cosine the same as? Secant. So 1 over cosine squared is the same thing as secant squared. Because of the reciprocal identity. And then sine over cosine squared. Do you see how there's kind of a mismatch? Okay. We could write sine over cosine, and that would be something, but we would still have an extra cosine in the denominator. Do you see what I mean by that? So what's going to happen is the sine over cosine, that can change to tangent, but then we have that extra cosine in the denominator, so we can change that to a secant. So we use the quotient and the reciprocal identities. Now this is where you might get frustrated, Mrs. Holman, how is that any more simple? I don't know if I have a very good answer for you on this problem because I don't know if that is more simple than what we started with. But we don't have a fraction anymore that doesn't have a crummy denominator. Okay? In this assignment, just really do what you can to try to get to the answer that the back of the book has. Okay? This is where I really want you to check those answers to see if you're getting to where you should be getting to. But I will not accept you not trying. Do you understand? I will not accept it. You will try each problem. I didn't give you that many, did I? I don't think I gave you that many. Okay? We're not going to do this problem, but what would you have to do in order to be able to add these together? Make common denominators. All right, this is our last problem. Oh, what happened? There it is. Did you get one? Okay, so this concept of trig substitution is something that I use in my calculus class. Okay. So it will be useful. Okay. What's happening is we have 4 plus x squared, but they are asking us to replace x with 2 tangent theta. Okay, now the issue is we cannot take a square root and break it up over addition or subtraction. Like the square root of 4x squared, that's stuck. All right, but watch what happens when we use trig identities. So we can replace x with 2 tangent theta like they asked, and when we square it, it becomes 4 tangent squared theta. Okay, now we're still stuck. We still cannot take the square root over addition. However, what is true about 4 and 4 tangent squared theta? What's in common? They both have a 4. So we can factor out that 4. All right, Mrs. Holman, well, what's the point of that? Look back at your notes. What is that the same as? 1 plus tangent squared is a Pythagorean identity that simplifies to secant squared theta. We no longer have addition, and we can actually take the square root of 4 to be 2 and the square root of secant squared to be You don't like it?
No.
Did you take algebra 3 last year? No, you came from algebra 2. Okay. Okay. It is okay if you are not perfect on this assignment. What I need from you is an attempt on every problem. We will do damage control tomorrow, and I promise you tomorrow you'll have more of an idea of where you're going to go with the problem, like when is the stopping point. But this is what I'm going to say about the lessons the entire week. The more you practice, the better you understand where to go with a problem. The more variety of problems that you do, the better you can do on future problems. So without practice, it's not going to happen. I will be very straightforward. Those of you who don't do your homework, this will not happen for you if you don't do your homework. Plain and simple.